And so here we go. So welcome. This is the May community call. We have a really nice agenda, actually. I'm very happy about this. We'll, as usual, talk about the Moddable SDK, the most recent update, which is 3.9. Then we'll have our special guest, Ishikawa-san, talk about some of his really great work recently on StackChan to integrate ChatGPT. I've had a chance to look at that, and it's really impressive stuff. He's also going to talk a little bit about why he's building on the Moddable SDK, which I think is really interesting. Then, kind of inspired by this this agenda, the Moddable team has put together some small gifts for StackChan that we will share after the presentation. I hope you like those. And then we have time for open discussion as people wish to hang out. And we have a really interesting group of people here today. So I hope you will have time to stay. So let's begin with the Moddable SDK, because that's really the foundation of everything that we do together. We do one release a month. This month it was 3.9. We encourage people to update to that version, so once a month, which is a stable and a recommended update. And in between releases are, more working copies. We always provide detailed release notes so that you can learn about new features, and you can find those release notes under the releases section on GitHub. There really are a lot of words in the release notes. I won't read them all to you, but it's great to give that a scan and understand what's going on and what new features are coming, what problems have been fixed. We always like to recognize the contributors to the release each month. So these are people who asked a good question, reported an issue, contributed some code, inspired a feature, and we're always happy to have feedback from folks, and we always recognize them both in the release notes and on this call. So thank you to everybody. Your contributions make this better for everybody, and that's really important. So this release, one of the main features is XS version 14. We tend to do an update about once a year, a major update to XS in the spring when the new version of the ECMAScript, the language standard, is released. And so that's going to be finalized in June. And so we release XS 14. The idea is always to keep embedded JavaScript developers up to date with the web so that whatever features of JavaScript you use on the web, you also can use on embedded devices. This time around, there's some new methods on array and typed array that make a copy when you change it. So these are really great for people who like to do functional programming style of work, methods like toReversed and toSorted. There's also some convenience functions that just kind of round out things that we're missing, like find last and find last index. So nothing too complicated, but some nice functions that can make your life a little bit easier when you're building your projects. We also always run through the full test 262 test cases to make sure that our version of JavaScript matches the JavaScript that you find on the web. And so there are a lot of little fixes in XS to things you may have never noticed needed to be fixed, but it's now even more correct in terms of its conformance to the web. So one of the really nifty features that I just wanted to talk about in depth briefly is a preview of a new language feature. So in the JavaScript language process, things go through stages. Stage 4 is when they're done. Stage 3 is when they're almost done. And so there's a really interesting proposal called Explicit Resource Management. And we're the first people to implement it. No other JavaScript engine has shipped it yet. And the idea is that when you're writing code, the Explicit Resource Management feature will take care of automatically freeing it when you're done using it. And as you know, on embedded systems, resource management is really important because resources are really limited. And so anything that makes it easier to manage resources, we think is really important. So I'm just going to give you the quickest look at what this feature might mean in your code. So today you might write some code like this, where you want to open a file, read a string out of it, and close it. The problem is, there's no error handling here. And if things go wrong, the file might not get closed. So as good engineers, good software developers, we add error handling. And all of a sudden, it goes from a simple function to something that's kind of messy. And when it's messy, it's harder to read, and we make more mistakes. With explicit resource management, we have this new keyword using, and we can just say using file, and then we create the file, we open the file, and what happens is when we exit this block, so when this function returns, file is automatically closed for us. And that happens whether there's an exception thrown or whether it returns normally. And so what this lets us do in this case is go from a function with no error handling, that was 4 lines, not have to write any error handling and get down to 2. And so we think this is really great because we can write code that's better, that works correctly in more cases, and it can be more compact. And so there's some other features with explicit resource management. You can read the spec, but if you want to play with it, XS is the first place you can try that out. And this is something we hope to be rolling out, is something that we really use as a default feature in the coming months. So that's one of the really cool features buried in this release. So there's also lots of new hardware support, and just to quickly run through that, for M5 Stack Core 2, which I know a lot of folks use with StackChain, now we have 16 megs of storage available by default. That means you can have bigger firmware images, you can do over-the-air updates with bigger files, and you can have a bigger file system. So really nice to be able to use everything that's there. We've added support for this Bosch BME680 sensor that's really popular and really complicated to support. And so if you are interested in the 680, take a look. There's examples there. It's a really powerful sensor, but a project to make work right. We support digital potentiometers now, capacitive touch buttons. We also continue to add support for new dev boards. So ESP32-S2 is really nice for small, inexpensive boards. So we support the Adafruit QT Py S2 board and the Wemos S2 mini development board. So we just kind of keep rolling these out one by one, 2 by 2, so that you can run the Moddable SDK on almost anything that's out there. So those are just a couple of the things that are in this release. There's tons more. So check it out. The release notes are there. While you're on GitHub, feel free to star our repository. It really helps people notice, and it gives us some encouragement as well. So that's Moddable SDK 3.9, just about on schedule. I'd like to introduce now our special guest, Ishikawa-san. He's the creator of StackChain, and as you saw from his book, he's been working with the Moddable SDK for a long time, and I think really one of maybe the main evangelist of embedded JavaScript in the Moddable SDK in Japan. And he's done a wonderful job creating StackChain. Not only is it a fun project, but the implementation and the technology is really great as well. And so with that, I will turn this over to Ishikawa-san. I'm really looking forward to this.
Okay. Hello, everyone. I will share my slides. Can you see?
Yes, looks great.
Okay. Okay, let's start. Thank you for inviting me to this Moddable community call today. I'm here to talk about StackChain. My name is Shinya Ishikawa. On social media, I go by the name Shishikawa or Meganetan. However, for some reason unknown, my Twitter account has been suspended for over a month. I wrote it an appeal, but I haven't received a response yet. This is the StackChain. Like me, it has also been suspended for a while. Is there anyone in the audience today who works at Twitter? I hope this call reaches Elon Musk. Today, I will be speaking about 2 main topics: explaining what StackChain is and discussing the integration of StackChain with ChatGPT. Let's begin with StackChain and its community. Nice to meet you, StackChain. This is StackChain. StackChain is a cute palm-sized robot that is open source. Our catchphrase is a communication robot in your hands. Being open source means that StackChain's hardware design data, such as circuits and outer casing, and all its programs are publicly available, so anyone can build or modify it. We have been sharing StackChain for almost 2 years now, And during this time, various individuals have created their own versions of StackChain. In this process, a natural gathering of StackChain community, essentially people who create and adore StackChain, has emerged. The StackChain community is mainly active on social media platforms like Twitter and Discord. And discussions about new creations and development are held every day. The direction that the StackChain community aims for is not one where specific companies or individuals are responsible for development like traditional robot companies. Instead, we aim for a relationship where everyone is a developer and a user. And we are working to expand the community in this manner. As of today, we already have 380 members who have joined our Discord server. Thanks to this, I never feel alone. Even when my Twitter account is suspended, I'm truly happy. While the main language used in our channel is Japanese, we have begun to gather people from overseas, and we are interacting in our international channels. If you are interested, please join us using the invitation link provided at the end of the slides. Thanks to the power of our community, StackChain has achieved significant growth. It won second place in the Hackaday Prize, a worldwide maker competition held by Hackaday in 2021. The judges commented, "Makers are usually busy with their own creations. It's impressive how StackChain has managed to involve a large number of people." Last year, we held a birthday party to celebrate StackChain's first year of development. About 20 members gathered to enjoy a StackChain cake. We even received celebratory message from the Moddable team. So thank you. We also exhibited at Maker Faire Tokyo. I'd like to take this opportunity to express my gratitude to everyone in the community. Thank you for always supporting StackChain. Now let's talk about ChatGPT and StackChain. The arrival of ChatGPT has had a huge impact on Japanese developers due to its performance, ease of use, and widespread adoption in Japan. The pricing model for ChatGPT varies depending on whether you access it via the web UI or the API. The use of the web UI is basically free, but access to the higher performance GPT-4 costs about $20 per month. The API, on the other hand, uses as a pay-as-you-go model, but the usage fee is very low. Also, Japanese input tend to use more tokens in the brain calculation than English inputs. Even heavy use during development costs me less than $5 or so per month. Mr. Robo, one of the oldest members of the StackChain community, equipped StackChain with it immediately after the API was released. He developed an AI StackChain that can interact with people using voice. Incredibly, it took less than a day after the API was released. This speed, combined with StackChain's cute responses, attracted attention and became a major topic, with tweets receiving up to 4,000 likes. Dr. Shane Gu, a technical executive at OpenAI who is responsible for Japan, positively responded to StackChain's integration with ChatGPT. He commented, "Nihon no kawaii wa saiko." Japanese kawaii is awesome. I had personally been waiting for ChatGPT for a long time. One of my goals was to create a robot that talks with people through StackChain. StackChain is already cute without doing anything, but I have been developing with a dream of a future where StackChain can provide advice to users, give praise and encouragement, and even engage in playful communication with other StackChains. I had thought that it would take another 1 to 2 years to fully integrate dialogue management. But with the arrival of ChatGPT, I feel like the future has arrived in a giant leap. So to achieve a robot that talks with people, I've started the ChatGPT integration on my own. Mr. Robot's original AI StackChain uses Arduino framework, so I re-implemented the whole part using the Moddable SDK. The internal modules of structures are all written in TypeScript. I also use TypeScript to write the ChatGPT client, and I utilize various modules provided by Moddable. Here's a brief video. He's introducing himself. He said, I'm Structure the robot. I'm good at responding the user's questions. Yes, it's ChatGPT inside, but ChatGPT plays as a structure robot. It has character. Okay, let's go on. Here, I have illustrated the overview of the ChatGPT structures process. The voice dialogue system is broadly divided into three parts: speech-to-text, STT, natural language processing, NLP, and text-to-speech, TTS. In each part, structure communicates with the external server in different ways. Let me explain each of these parts in order. First, let's talk about the speech-to-text, STT part. An external server recognizes speech. I use the Node.js binding over speech recognition software called WASC. I wrote a very simple server program using WASC. The server sends the recognition result to Structure via WebSocket. As soon as Structure receives the result, it forwards it to the next natural language processing module. Next is the natural language processing, NLP part. Here, all we do is call the ChatGPT API. Thanks to ChatGPT, we can leave all of this part to the API, including the parts of language understanding, dialogue management, and response generation. But this is the main part. Perhaps I should speak a bit more about it. The structure of the ChatGPT API is incredibly simple. In the request, the user includes the entire chat history up to this point. As shown in the figure, the chat messages are lined up in an array in chronological order, with the last recognized user message added to the end, at the end. In response, one appropriate assistant message is returned. I use Moddable's HTTP client with a TLS socket. It's convenient because Moddable takes care of the complex processes of the TLS connection. By the way, you might be wondering what the system message in the request is. This is a special type of a message included in the chat history that can contain character setting for the robot or a special instruction for interaction. This makes ChatGPT respond as if it were structure. Finally, let's talk about text-to-speech. Here, too, we use an external server. We use VoiceBox, a Japanese text-to-speech engine. It has a built-in web server function and can be launched quickly with a Docker command, which is very convenient. With the instruction, we use a class called WebStreamer. If we try to hold all the web data after sending the request, the memory would be exhausted quickly. So we divide the received web data into chunks and send them securely to the private queue. This way, we can keep the memory usage below a certain level while playing any length of audio. By the way, you may have noticed that Structure's mouth moves as it talks. This is indeed synced with the voice. Another important function of WebStreamer is that it executes the callback every time the chunk of playback finishes. Here we calculate the volume of the audio just played and map it into the opening of the mouth, achieving lip sync. Okay, that's a rough explanation of the process. So let me briefly explain why I choose to use Moddable. First of all, my previous job was as a web front-end engineer, so I love JavaScript. On the other hand, I was a novice in embedded development. Having to acquire knowledge specific to embedded development in addition to running C++ was a pain point. With JavaScript, I could easily get started. Moddable is actively developed, but I was concerned about whether the application I created would continue to work stably with future updates. In that respect, the standardized APIs by ECMA were attractive. Also, I appreciate the fact that even the features specific to embedded systems were thoroughly tested. Finally, StackChan uses a development board called M5 Stack. Moddable is compatible with many modules and sensors in the M5 Stack series, which makes it easy to expand. Finally, let's talk about future work. There are many things to do, but here I introduce 4. First, I'd like to implement smarter dialogue management. Right now, StackChan tries to answer every sound it hears from the microphone. This can be a bit annoying because it interrupts all conversations, even ones between people. I want to make it smarter, like how smart speakers work. They only react when they hear a specific word or phrase. Also, the new M5 stack that was released recently has a camera on it. I'm excited about this because we might be able to use it to make StackChan react when it sees people's faces. Isn't that exciting? Second is performance improvement. Right now, StackChan takes about 10 seconds to respond after it hears someone speak. But when we talk each other, we usually respond in less than half a second. So there's an awkward silence while waiting for StackChan to respond. I'm planning to work on this and make it faster. The biggest hold-up is how long it takes to get a response from ChatGPT. That can take between 5 to 10 seconds. But there is this cool thing with the ChatGPT API where it can send back results a token at a time as they are ready. This is called Event Source API, and it's something Moddable can handle. I'm really excited about it. Third is support for foreign languages. The voice box I use this time is limited to Japanese. I want to support speech synthesis engines that support world languages, such as Google TTS. Lastly, I am considering releasing StackChan's functionality as a module for Node-RED MCU. I'd be happy if even those with little programming experience could create robot applications. And Node-RED MCU can quickly and various sensor nodes. I want to apply these StackChan's interactions. Imagine StackChan speaking not only in response to user speech, but also triggered by sensor values. For instance, saying something like the CO2 concentration is high. How about opening a window? Sounds cool, right? I will continue to develop StackChan in the future. If you would like the latest information on StackChan, please join us on Discord. Let's enjoy making super-kawaii robot together. That's all for now. Thank you for listening.
Oh, that was great, Ishikawa-san. Thank you.
Thank you very
so much. It's truly inspiring to see what you and your community have created. It's really a great motivation for all of us working on the SDK. So thank you. I wanted to ask you one question, if it's okay.
Yep.
You know, one of the things I love about the project is that you really make it about learning, about teaching people so that they can do things themselves. And when you present this, you make it look very easy. You know, but you've solved some very hard problems. And so do you have any advice for people who are kind of learning and getting started for how they can get past the frustration, how they can kind of step by step learn how to do more with StackChan?
Ah, okay. Yeah. Recently, especially recently, many people has joined the StackChan community. Thanks to the power of ChatGPT and AI StackChan. And yeah, I know they know less about programming or embedded development. So yeah, many they give many questions for us. Yeah, one thing I can say is the important thing is to respond quickly. The quick response, even if this is the correct, right response, quick response makes people has that they feel like so I mean no response at the first question makes people feel abandoned or not encouraged. You see.
No, I understand. I understand. No, I think that's really important. I think the interactive communication really helps people to learn, and your discourse is really good at that.
Yes, be interactive.
Yeah, cool. So what I'm gonna do now, I think probably many people have questions for you. I want to do the last step on the agenda, and then we can have kind of an open conversation with everyone, if that's okay. So I'm going to share my screen here for a minute. Let me see if this works. Don't be surprised if something strange happens. Share, boom. Okay. So as I mentioned at the beginning, this talk, once we scheduled it, was kind of an inspiration for the Moddable team, and so we thought about what things we could do that might be helpful for StackChan, and so we did a little bit. Let me see if I can walk through these. So number one, StackChan community has so many great ideas, but they don't all fit into StackChan because memory is limited. And Ishikawa-san, you talked about that a little bit when you talked about audio streaming and the challenges there. So we want to enable the external RAM that exists on the M5 Stack Core 2 so that there's more space. And we tried that. And what we found is we go from about 300K of memory or a little bit less to almost 4.4 megabytes of RAM. So about 16 times more RAM. And so that really makes it possible to do all kinds of exciting new things and to pack more features together. So we're happy about that. And we hope in the future we can enable PSRAM for more devices. It's sometimes tricky and sometimes easy, but we think that's going to be really, really great for StackChan, we hope. So that's number one. Number two is MP3. So StackChan should sing, really sing. And so we have added an MP3 decoder so that we can play kind of traditional music files and keep them nice and small. And we made a resource streamer so that we can play them from flash memory. And we made an HTTP streamer so that we can stream them from radio stations and files that are on the open internet. And it's extremely low latency, as I'll show you in just a minute. And conveniently, it works with HTTP and HTTPS streams. And there was some bug fixing to get the HTTPS streams to work. And so one thing that we have to kind of show how that this new MP3 capability works is, let's see if I can get there. We have a new Soma FM application. And I'm going to try to play this. Oh my God. There we go. Let's try. There we go. So this is all the stations on Soma FM. When we pick one, you see it starts playing almost immediately. We can change the station. And again, it starts playing almost immediately. Of course, we can adjust the volume. And that low latency is, we think, really important for your goal of having StackChan respond as quickly as possible. So you should never have to wait to be able to hear something when you start playing an audio stream. So MP3 with streaming is the second. And then the third one and final is built on top of that, which is text-to-speech in the cloud. And we did this using 11 Labs. We actually got this idea from your Discord. One of the users in the international channel mentioned it. And so 11 Labs text-to-speech sounds fantastic. It is built using MP3 streaming. So the only way to play it and work with the service is if you have MP3 streaming. We put a really easy to use API around it. And the approach can then be adapted, we think, for other cloud engines. So you could use it, for example, with Google text-to-speech, we think is possible to implement in a similar way. And I wanted to give you just a super quick demo of this as well. So I'm going to switch my screen sharing. Boom. Let's see if I can do this correctly. Sorry. Oh, there we go. One of these is moving. I think this one. So you can see a strange terminal window. And I have an M5 stack core here. You can see it here, right here. I think you can see the device in my video. And in this window, I can give it a message. So if I say, hello, Moddable community members, for example, this sends an MQTT message, which will be received here. And let's see what happens.
Hello, Moddable community members.
So there you go. And so we can put anything in here. So for example, we can say, Ishikawa-san. Oh my God, it's hard to type. Ishikawa-san gave a fantastic, inspiring presentation. We do that and hit it, and here we go.
Ishikawa-san gave a fantastic, inspiring presentation.
And, we can do all sorts of nifty things with this service. It's very expressive.
Ishikawa-san gave a fantastic, inspiring presentation.
She's not sure, but it was great. But so you can see the text-to-speech works very well. And it's just a few lines of code to integrate that and can run on just about any ESP32. So those are three things that we've been working on to help StackChan in the community. And the fun news is that these are available right now. During this call, we pushed version 3.9.2 of the Moddable SDK. So you can try these out, whenever you happen to have some spare time this weekend. So some pretty useful, I hope, new features available for StackChan and everybody else building with the Moddable SDK.
Thank you very much. Oh, I will try it this weekend. Yeah,
cool.
I'm really surprised to one of my feature work get done. So yeah, I will try it ASAP.
Well, yeah, we should keep a shared to-do list somewhere so we can help each other. There may still be a bug or two in this, so please, if you run into problems, just let us know.
Okay, I got it.
Cool. So that's the end of the call. Thank you, or the end of the formal part of the call. Thank you, everybody, for joining us. Really appreciate it. Ishikawa-san, again, thank you so much for your presentation and all your work to build community and teach and share with people. It's really inspiring. It's really great. And
thank you very much.